Okay, so let's take a look at the review for the fourth quarter. So number one says to solve the square root of 7x minus 10 is equal to x. Okay, so what you want to do is start off by rewriting the square root of 7x minus 10. So that's 7x minus 10, and the square root, remember, is a 1/2 power equals x. To get rid of the half power, you multiply by the reciprocal. The reciprocal of 1 over 2 is 2 over 1. I'm going to raise that to the 2 over 1 power, which is just 2. So these will cancel each other out. So I get 7x minus 10. 7x minus 10 is equal to x squared. So it is a quadratic, so we want this to equal 0. So I'm going to move everything over to the right. So minus 7x, add 10. So I get 0 equals x squared minus 7x plus 10. All right, so now we're going to factor this. So I'm going to multiply the first times last. I get positive 10x squared. What multiplies to 10 and adds to 7 would be 5x and 2x. But they multiply the 10x squared and add to 5x. They have to be the same signs. They both have to be negative, so that I get negative 7x. Bring down the plus 10. Bring down the x squared. And then we'll factor by grouping. So the GCF of the first group is x times x minus 5. The GCF of the second group is negative 2 times x minus 5. So my factors are x minus 2 times x minus 5 equals 0. T-chart, we get x is equal to 2 and x is equal to 5. And you do have to check it. You have to check it into the original up top. So the square root of 7 times 2 minus 10, does that equal 2? So 7 times 2 is 14. 14 minus 10 would be 4, so it's the square root of 4 equals 2. Yes, 2 equals 2, so that checks, so 2 is a good answer. We have the square root of 7 times 5 minus 10 equals 5. 7 times 5 is 35, minus 10 is 25, so it's the square root of 25 equals 5. Yes, 5 equals 5, so that checks, so they're both good answers. All right, let's take a look at 2. Okay, so a student has test scores for the last 4. This 4 should actually be 4, F-O-U-R, the number 4. The last 4 tests were 80, 86, 96, and 82. What score does he need on the next 2 tests so that the mean, that should be the of all 6 tests is a 90? So what I'm actually looking for, I mean, there could be a few different answers, but I'm going to look for what would be the average of those 2 test scores. All right, so remember, to find average, you add up all the numbers and you divide by 2. So these are my divide by how many numbers you have. So these are my scores. I have 80, 86. So I have 80, 86, 96, 82. Those are my 4 test scores. Now I want to know, what do I need on the next tests? I'm going to call them X. And when I add up all my scores, which are 6, it has to equal 90. All right, so 80, so we're going to combine like terms on the top. So 80 plus 86 plus 96 plus 82 is 344. X plus X is 2X. Divided by 6 equals 90. Put 90 over 1 and cross multiply. So I have 540 equals 344 plus 2x. Minus 344. I get 196 is equal to 2x. Divide by 2. X is equal to 98. So I would need a 98 on each of those last 2 tests for me to have an average of a 90. I mean, like, it could be, though, that you get a 99, 97. That would be the same thing. But this would be the average of those 2 tests. All right, let's take a look at number 3. Okay, so number C says 3. It says express using radical notation. So I'm just going to rewrite all of these guys here. All right, so the first one we have x, y raised to the 4/5 power. Remember, a fractional exponent is power over the root. The only thing being raised to the 4/5 power is y, because this is x times y to the 4/5 power. So it's only going to be the y. So it'll be x, the 5th root, because that's my root power over the root. The root is 5, of y to the 4th power. All right, now take a look at B. We have in parentheses xy raised to the 4/5 power. So that means both of them are going to get a power of 4 and be the 5th root. So it'd be the 5th root of xy. So you could write it like this, xy to the 4th power, like that. Or the 5th root of x to the 4th, y to the 4th, since they're both being raised to the 4th power. All right, let's take a look at C. We have xy raised to the negative 4/5 power. Remember, the rule for changing an exponent to a positive, remember this rule, we have x to the negative n power is 1 over x to the n power. It takes whatever its base is, in this case my base is y, and it shoots it into the denominator. With the exponent, it makes it positive. Now, the only thing that's being raised to the negative 4/5 power is y. So it's going to be x over y to the 4/5 power. And then we'll do power over the root. So it's x over the 5th root of y to the 4th. And the same thing with the last one. We have xy raised to the negative 4/5 power. Since the whole thing is being raised to the negative 4/5, it's 1 over xy to the negative 4/5. Positive 4/5, sorry. Right, becomes positive when you put it in the denominator. And this would be 1 over the 5th root of x to the 4th, y to the 4th. All right, let's take a look at 4. Okay, so 4 says solve by completing the square. All right, so when we complete the square, we want it to equal the constant. So I have to minus the 6x. So I get x squared minus 6x is equal to negative 8. Now I'm going to do half of b, which is negative 6. Half of negative 6 is negative 3. Squared is positive 9. Add that over to both sides. So I get x squared minus 6x plus 9 is equal to negative 8 plus 9. Negative 8 plus 9 is positive 1. And then I factor this side. Now remember, I showed you a quick way to do this, that inside your parentheses, this number here is always the number you got when you did half of b. So when I did half of b, I got negative 3. So this is minus 3. So I have x minus 3 times x minus 3, which is x minus 3 squared, because I have 2 of them, equals 1. To get rid of the square, you square root it. So I get x minus 3 is equal to plus minus. The square root of 1 is 1. Don't forget that plus minus. And then I will add 3. So I get x is equal to 3 plus minus 1. I'm going to split it now because I have 2 roots. X equals 3 plus 1, which is 4. And x equals 3 minus 1, which is equal to 2. All right, let's take a look at 5. All right, so we have the probability that the Mets will win is 2/3. The probability that the Mets win both Monday and Tuesday is 1/6. Determine the probability that the Mets will win Tuesday if they win on Monday. Okay, so this is a given. This is conditional probability. It's a given. All right, so the probability that the Mets win, I'm just going to write this down, on Monday is equal to 2/3, and the probability that they win on Monday and Tuesday is equal to 1/6. All right, so what I want, though, is I want the probability that the Mets win on Tuesday if they win on Monday. So that means they have to win on Monday. So the probability of, given that it's Monday, that they win on Tuesday. All right, so that's the probability of T and M over the probability of M. The probability they win on Tuesday and Monday is, that's given, 1/6. Over the probability they win on Monday is 2/3. Plug it into your calculator. You can put make sure you put parentheses around that. And when you plug it in your calculator, you get 1/4. Okay, let's take a look at 6. Okay, so we have here the terminal side of angle theta passes through the point -2, 5, and you have to think, what quadrant is this in? This is in quadrant 2. Determine the following: sine, cosine, tangent, cosecant, secant, and cotangent. So we're in quadrant 2. So we're going to draw a picture of our angle that terminates in quadrant 2. Okay, so we have -2, 5 is in quadrant 2, so that's up here. Okay, so here's my angle that passes through the point. So the angle is the angle that's in standard position, which would be this angle, but that's not going to help me, right? So I don't want to use that angle. What I want to use is the reference angle. So remember, the reference angle and the given angle are the same. So I'm going to use my reference angle. So what you're going to do is from the point, you're going to drop the altitude. Now, if this point is -2, 5, my x value is -2, my y value is 5, I need that side right there, which is the hypotenuse. All right, so we use the Pythagorean theorem. A squared plus b squared is equal to c squared. So I have 5 squared plus -2 squared is equal to x squared. So that's 25 plus 4 equals x squared. X squared equals 29, so x is equal to the square root of 29. So this here is the square root of 29. All right, so now we need to do sine theta. So now remember SOHCAHTOA. All right, so now I want sine theta is opposite over hypotenuse. So opposite theta would be 5 over the hypotenuse, which is the square root of 29. We'll rationalize the denominator, multiply top and bottom by the square root of 29. So it's 5 the square root of 29 over 29. Okay, now let's just go to the reciprocal of sine. The reciprocal of sine is cosecant theta. So cosecant theta is the flip of sine theta. So I'm just going to take this guy and flip it. No need to go to this one over here. Right? I don't want to go from here because then I'm going to have to rationalize again. Go from here and then you won't have to rationalize. So flip it and I get the square root of 29 over 5. Okay, so now we want cosine theta. Cosine is the adjacent over the hypotenuse. The adjacent side is -2 over the hypotenuse, which is 29. Rationalize the denominator, multiply top and bottom by the square root of 29. We get -2 the square root of 29 over 29. And the reciprocal of cosine is secant. So I'm going to go from here, and I'll get negative the square root of 29 over 2. All right, now tan theta. Tan is opposite over adjacent. So opposite would be 5 over -2. So it's just -5/2. And then cotangent would be the flip of that, which would be -2 over 5. All right, and let's take a look at 7. Okay, so from a standard deck of cards, one card is drawn. Determine the following probabilities. All right, so you pick a card. There are 52 cards in a standard deck. The probability that you get an ace. So there are 4 aces in a standard deck of cards, so that would be 4 out of 52. The probability that you get a black card. So the black cards are the spades and the club. So there's 13 of each suit, so that's 26 out of 52. That's a 6. The probability that you get a king and it's red. A king and it's red. So basically I want to know how many red kings are there. There are 2 red kings. So that'd be 2 out of 52. Okay, and then I want a spade or a heart. So this is your or. The probability of a spade or a heart would be the probability, I'm going to write it on underneath, the probability of a spade plus the probability of a heart minus the probability of a spade and a heart. All right, the probability that you get a spade is 13 out of 52. The probability that you get a heart is 13 out of 52. The probability that you get a heart and a spade at the same time is 0. So this is a mutually exclusive event, which is 26 out of 52. All right, let's take a look at number 8. Okay, so number 8 says solve for x. So it's a, remember this is called a fractional equation. What you want to do is get rid of the denominator. So let me rewrite this. What I want to do is get rid of the denominators. So I say to myself, I'm going to start over here on the left side with my x down here. What do I need in the numerator to get rid of the x? I need an x. So that means I have to multiply everything by x. Now this x here takes care of this x. This x here takes care of this x. This x here does nothing to the denominator. So how do I get rid of the 3's that are left? So I have to multiply everything by 3. 3. So I'm multiplying all the numerators by 3x. Now I'm going to reduce. So this x reduces with this x. So I'm left with 3 times 3x plus 2 equals 3x and 3x reduce. So I'm left with 4x minus 2. And then 3 and 3 reduce. So I'm left with 1 times x is x. So we'll distribute. I get 9x plus 6 is equal to 5x minus 2. Minus 5x, I get 4x. Minus 6, I get negative 8. Divide by 4, I get negative 2. The last thing what you want to check for is just make sure that your value you get for x doesn't give you anything that's undefined in the denominators, but you're good. All right, so let's take a look at number 9. Okay, so number 9 says, determine which statistical study is being represented in each situation below. A student decides to do a statistical analysis of the rainfall in a certain area of the country over a course of a specific 30-day period. So this is an observational study. And the reason why it's observational is because she's not going to do anything. She's just going to measure how much rain that happens in that area. All right, now number looking back, I didn't like B. I didn't like how it was worded. So what also you would need to know is how to do an experiment. What would you have to have for an experiment? That an experiment, you would take your group and put it into take your group of people, put it into two equal groups. And you would have to give one group, implement something to one group, such as whatever, if you're testing aspirin or something that, you know, would not cause heart attacks. Give one group aspirin and one group a placebo, and then compare the results at the end. Okay, so let's take a look at 10. All right, so 10 says, show that this is equal to this. So show, this word show means it's kind of like a proof. You have to show that it's actually true. So this here is a division problem. What you need to know is you never, when you're going to show something, never ever cross over to the other side. So there's two different ways you could do this. I'm going to show you which I think is the easiest way. Is that is to take this here and actually do long division to this. And when you do long division, since it says to show that it's equal to this, which means it will be, you should end up with this when you're done. Okay? So you're never, though, going to move anything from one side of the equal sign to the other side of the equal sign. Okay, let me just clear the screen here. Okay, so remember, it's a show. We want to show that this side over here is the same. When I do this division, I will get this as my answer. I want to show that these are actually equivalent to each other. So you never move things back and forth. You are never going to cross over this equal sign. You're going to work on one side, and I would work on this side because this is what you know how to do. This is what we've done in class. You could work on this side. I could show you, but I think it's easier to do this side. I could show you in class. If there's anyone that wants to know how to do this side, I could show you in class. All right, so it's a division problem. So it's x plus 3 divided into x to the third. Now notice there's no x squared, so you have to put in plus 0x squared minus 6x plus 13. All right, so I have an X here. I want to know what will give me, I want to know what will give me X to the third, so that's X squared. Multiply down, I get 3X squared. And X squared times X is X to the third. Minus, make sure you minus, so X to the third minus X to the third is 0. And I have 0X squared minus 3X squared is negative 3X squared. And then bring down the negative 6X. And then I need to get a negative 3X squared, so that's going to be negative 3X. So I have negative 9X when I multiply down, minus 3X squared. Now I'm going to minus. When I minus a negative, that becomes a positive here, right? So this is positive, positive, and positive there too. So that cancels out. So I have negative 6X plus 9X is 3X. Bring down the 13. And I need a 3 up here. Oops, sorry. Thought it was in blue. I need a positive 3 up here so to get a 3X like I have here. So 3 times 3 is 9, positive 9. 3 times X is 3X. Okay, subtract them. The 3X's cancel out. 13, make sure you subtract 13 minus 9. 13 minus 9 is 4. So that's my remainder. So remember, we write this as X squared minus 3X plus 3 plus my remainder over my divisor, X plus 3. And notice, and that equals, if I bring this side down, X to the second minus 3X plus 3 plus 4 over X plus 3. And notice I never crossed over to the other side. I never crossed over the equal sign. All right, let's take a look at number 11. I got to flip pages too. Okay, so the blood pressure P and weight W of resting animals at the Northside Zoo were measured as shown in the accompanying diagram. So I have my W is the weight and P is the blood pressure. This is going to be my X and this will be my Y because the blood pressure is dependent upon the weight. It says to write an exponential regression equation that models this data, rounding any decimals to the nearest thousandth. Okay, so let's start. You have to plug this data into your calculator, right? You're going to do L1. This will be L1. This is L2. This is your X. This is your Y. All right, and you want to do your exponential regression equation, so plug that into your calculator. And you're going to, the first thing you're going to do is write down your entire calculator screen, which is Y equals AB to the X power. A equals 104.803. 6515. Don't round anything until we write the equation. B equals 1.004435616. R squared is 0.964933388. And R is 0.98231023. Remember, R is the correlation coefficient. That just tells you how strong the correlation is between the two data. It is 0.98, which is a very strong correlation. All right, now we're going to plug A and B in, and this is when I'm going to round to the nearest, let's look, I don't remember what it said. Round to the nearest, where are we, thousandth here. That would be 3 decimal places. So that would be Y equals A, which is 104.804, times B, which is 1.004, raised to the X power. That's the regression equation. Okay, the next part says, using this equation, predict to the nearest integer the blood pressure, so I'm solving for Y, of an animal that weighs 160 pounds. That means my X, because that was my weight, X is equal to 160. So just plug it in. Y equals 104.804 times 1.004 raised to 160. Plug that into your calculator, and the blood pressure would be 199. Okay, and the last one, I'm going to have to move everything up. Okay, I need that equation though. All right, last part, using the equation, predict to the nearest integer the weight of an animal with a blood pressure of 225. So blood pressure being 225, that would be my y is 225. I'm looking for the weight, which means I'm looking for x. All right, remember I always say, I'm looking for x. Blood pressure is 225 equals 104.804 times 1.004 raised to the x power. I'm looking for x. Notice that x is in my exponent, and right away you should be thinking at some point you're going to have to use logs. All right, so let's get rid of the 104. So divide both sides by 104.804. And I get 2.146864623 equals 1.004x. Now you only have your base with the exponent. This is when you log both sides, so it's a log. 2.146864623 equals x log 1.004, because the x goes in the front. That's that rule. Divide both sides by log 1.004. So I get x equals, and we get 191. Okay, and the last one is 12. Okay, so Sancho is a physical therapist who specializes in leg injuries. His patients differ in age and types of injuries. All right, so it says first thing is to complete the table. All right, so from 0 to 12 years old, we have eight people, 8 kids have knee pain, 3 people have ankle pain, so that's a total of, you have to add them together, 11. The people that just have ankle pain is 6. All together here, this has to add up to be 17. So if this is 11, that means this must be 6. So if this is 6, that means this has to add up to be 6. So this is 3, and then this would be 11 there. All right, find the probability that a patient has knee pain given, so I want the probability has knee pain given he's 13 to 19 years old. So remember, you're only looking in this column, 13 to 19. You don't want to look at any other column. So we're not looking at this row actually. We're only looking in this row. And I want the ones that have knee pain. There are 3 out of 6. And the last part, it says the probability that a patient has ankle pain, or, so let me get rid of this. This was 3 here and 11. The probability that the patient has ankle pain or is a 13 to 19. So on probability of ankle pain or 13 to 19. All right, so it's the probability of ankle pain plus the probability of 13 to 19 minus the probability that it's ankle pain and it's 13 to 19 years old. All right, so it's not a conditional probability, so I have to look at the whole thing. What's the probability that a patient has ankle pain? There are 6 out of 17. So this here would be 6 out of 17 plus the probability that it's a patient between 13 and 19 years old. So there's 6 out of 17. The probability that they have ankle pain and they're 13 to 19 years old. Ankle pain and 13 to 19 would be 3 out of 17. All right, so 6 out of 17 plus 6 out of 17 is 12 out of 17. Minus 3 out of 17 is 9 out of 17. Okay, that's it. And happy studying. Do the worksheet over and over again. And I'll see you tomorrow in class. Have a good night.